Hello, fellow Scratchers! Man, I love this Scratch Raycaster series, and I'm very excited to be coming back to add something new. If you haven't yet followed along, then now is a great time to start. Episode 1 and 2 are dead simple, seriously fun, and wow, I can hardly believe the progress we've made since then. Which brings us back to today, and we're going jumping mad, adding the ability to jump over Nano and generally jump all around the level, because it's far too much fun. How cool is this? So, currently we only store a player X and Y position on the map. Now we're going to need to add the player's vertical position too, player Z. And in episode 8, we already covered panning the scene up and down, but jumping is a little different, as the parallax effect requires further away elements to pan slower than those up close. Oh wow, look at all the tiny enemies spread around the level. That is so fun. And so, if you've already caught up with episode 9, shout "I'm ready" in the comments, and if not, then not to worry, you'll soon catch up, because without further ado, we'll save our projects as a new copy, for this is episode 10. Guys, let's get scratching! Okay, so before we lay down any new code, to make testing easier, I want to temporarily disable the mouse controls. Don't worry, we'll put them back at the end. In the player sprite, scroll down to the define player tick script. This is where all the player movement happens. I'm going to separate off all the mouse control code. That's everything down to and including the first turn by degrees block. And to make things clear, let's wrap that in a custom block, naming it mouse controls, and run without screen refresh. So we can attach the new define hat block to those mouse scripts. And then we'll make use of the mouse controls block right away. However, we are temporarily disabling the mouse controls, aren't we? So bring in an if-else and drop the new block in the first then branch. Cool. Bring back the rest of the scripts from below, popping them in on the end of our if. The else block simply wants to set camera Y to 0 to ensure that we're looking straight ahead. Note that an empty if condition will always run the else branch, so our mouse controls are now disabled. I'm just going to move that mouse controls definition into some free space down here. Excellent, give that a quick run to confirm it works. Here come the nanos. Yes, I can wave my mouse around and it no longer rotates the view. Instead, I am forced to use the keyboard. Also, I don't really want the cursor to follow my mouse either. So to fix that, we can pop a set pointer lock into the else branch too, setting it to 1. And now the pointer becomes locked to the middle of the screen, and we are running 100% mouse free. I would also like to disable the enemy movement, as they can often get in the way far too quickly when we're testing. So click into the entities sprite and scroll down to where the when I start as clone script is. And this is the simplest change. Just separate off the move custom block and do leave it nearby so that we can restore it later on. Haha! These enemies are out of luck, but that is much better for testing. Well then, let's have some fun. Click into the pen sprite. This is where all the 3D drawing gets done. Specifically, in the define draw row block. And now we are going to add player verticality. You can see this is where we calculate the height of each vertical slice of wall based on its distance from the player. And here is where we work out the top Y position to begin drawing the wall downwards. This is what we'll need to tweak. But first we'll need to make a new variable, player Z, to keep track of that vertical position, making it for all sprites. And for fun, switch the variable reporter to be a slider by right-clicking it or with a long press on mobile. So, as I now slide this upwards, I want the player to appear to rise up off the floor. The effect of this is that the level should move downwards. If you can remember way back to, gosh, like episode 2 of this series, is it? Then this 1.5 represents how tall above eye level each wall starts. So, to shift this wall downwards by player Z, we'll use a subtract block, subtracting our player Z from the same 1.5 value. Now, we don't need to worry about further away things moving slower, as this is already accounted for in the height variable. But we do need to compensate for it being multiplied by 10, so we divide player Z by 10 first. Finally, we can drop that in place of the existing 1.5. Oh, that line is getting a bit long for my liking, but I'm going to let it slip this once because it is testing time, so slap that green flag. Oh man, yes! See how easily the level now drops away below us. I'm really loving that. It's just too much fun trying this out all over our level. But we do have to do something about these enemies. The same vertical positioning should be being applied to them too. What we will need is to duplicate this math script up to where we're multiplying by height. And then, moving over to our define stamp entity script, this is where we, stamp our entities on the screen. But enemies don't have a vertical Z position specifically. So we're going to replace this 1.5 for a 0 to represent that position, and then simply drop the script into the goToXY on the left there, replacing the blank value. Super easy, right? Well, smash that green flag! Oh yes, did you see that? I am liking what I saw. The entities are now behaving exactly as we'd hoped, keeping their feet firmly on the ground as I raise the player up and down. Hey, like this, it makes me feel really tall. However, as fun as it is to look down on our level from above, the rendering of the level from above will never look quite right, as our Raycaster is optimized to not draw any walls behind the first wall each ray encounters. As well as this, we have a virtual ceiling in place, and we are not supposed to be able to burst through it. If you come up close to a wall and adjust the player Z value, you should find this looks fine up until around 13 or 14, but any higher and the illusion is lost. So we'll have to remember that as we scrap the player Z slider and code up some actual player jumping scripts. 13 or 14 is the max. So click with me into the player sprite. And yes, we still want the player tick script, only scroll right down to its bottom. Now we're looking out for when the player presses the space key, if key space is pressed. But we only want to jump when we are touching the floor. So another if, checking when player Z is equal to simply 0. That'll be the floor. Okay, now we need some vertical momentum to jump up with. Make a new variable, player speed Z, or player SZ for short, for all sprites. Now, when we successfully jump, we set player speed Z to not too much, let's try 2. Then, to move the player up by this speed, change player Z by the player speed Z, SZ. Except we need to remember all our movements are scaled by our delta value to allow for slow frame rates. So change player Z by player speed Z multiplied by delta. Next, we account for gravity. Change player speed Z by negative 0.2. Again, we need to multiply that by delta. All that's left is to prevent the player falling through the floor. If player Z is less than 0, then they've fallen too far, so simply set player Z back to 0. But also, let's reset the player vertical speed. Set player speed Z back to 0 also. And are you ready for this? Run the game! and press space. Boing! Boing! Oh man, that's awesome. And if you look, our height is not going much above 10, so we are well within our acceptable parameters. Testing next to a wall? In front of Nano? They must think we are looking most odd. Hey, I wonder if we can... Oh yes! I know exactly what we are going to work on next. Jumping over enemies. Of course, we'll need to account for the fact that some enemies are taller than others. Frank! So, we are in the player sprite, and here is where we detect that the player is touching an entity. And for reference, we are still in the define player tick script. Yes, it's all happening in here today. Now the problem is, touching entity doesn't tell us what type of entity we touched, be that a nano or a much larger Frank. So that's not going to work here. We need to pull out the if touching entity script and make sure to reattach the other script from below. Right, we're going to move this touching script into the entity sprite instead. So before we do, click first into the entity sprite. And yes, this is actually where we're going to do the work, in the when I start as a clone forever loop. We'll make a new custom block named hurt player, and we'll run without screen refresh. Now drop the new block into the forever loop so it runs each game frame. And now we need those touching scripts from the player sprite. Click back into the player and drag them right into the entity sprite. Right, they should have appeared somewhere nearby, so attach them to the define hurt player hat block. But careful, notice how we are looking for touching entities? This is no longer correct. We are now wanting to know if the entities are touching the player, so make sure to switch that around. A wonderful benefit of detecting the collisions this way around is that each enemy can now control if and how much damage they inflict on the player. We just need to code it up right here. But for now, let's just confirm this is working as expected. Yep, touching Nano is a constant health drain. However, it's not super obvious that we are taking damage, is it really? Often first-person games will flash a colour on the screen to indicate damage has been inflicted. So, we're going to add a broadcast whenever the player is hurt, broadcasting a new message, player hurt. The pen rendering is all done in the pen sprite, so click in there now, and we're going to create a new costume for this, and zooming right out of the canvas, draw a huge rectangle over the entire painting area, snapping it to the centre if you can. Now I don't want an outline, but the fill, that is important. We'll switch to a radial gradient fill, and the centre, that's the left-hand colour swatch, click that, and make it transparent. Then the right-hand swatch. We want a deep red, around a brightness of 60 or so. Now if we can make that visible on stage, you can get a picture of what we are looking at. Perhaps set the size to 100 and the X and Y position to 0, 0. There we go. That should work great. Shall we code it up? Find some space and we'll trigger off a when I receive for the player hurt event. Okay, so we're going to switch to the new hurt costume. And then we'll make sure the size is set to 100. Also, a clear graphics effect would be a good idea to reset any brightness or ghosting effects. Then position the sprite in the center of the screen with a go to XY 0, 0. And finally, from the pen category, we stamp our hurt costume on the stage. Splendid! Are you ready to see this in action? We're approaching a dangerous Nano. And there it is! Our red overlay is working perfectly. Down goes our health, and we are well aware of that because we can see the red coloured border around the screen. Cool. And now we are all set up to add the most awesome of Scratch sports, Nano Leapfrog. Right now, no matter what we do, we continue to collide with this little guy, but not for long. Look here, still in the pen sprite, you can see that the costume 1 is a nano, and we no longer want to collide if the player's Z value is greater than their height. Now, costume 2 is a franc, and they are simply too tall. Jumping will still result in the player getting hurt. Okay, then click back into the entity sprite. Before we check for touching the player, we'll drop in a new if check. And we need an AND, so we can check if type is equal to 1. For that is a nano. And if player Z is greater than around 3, then we are jumping over their head. Well, if we are jumping, then we won't be able to collide with any nanos, so we can stop this script and not bother to check for collisions with this entity. Wow, that was quite easy. Question is, does it work? Smash that green flag! I'm testing walking collisions first, and yep, that works as before. Now with a run-up, jump! And I didn't see a flash. And no, not a single health point was lost. That is great. Let's do it again. Whoops, I think I just caught them there. Come on. Hurry up! Yeah, got it. Hey, you know, we could easily add a score counter and track how many nanos we jumped over, and that would be too fun. Hold on, let me just find a Frank. Frank, where are you, Frank? Aha! Okay. Jump! Ouch! Yes, as hoped, jumping has no effect on reducing collision pain from touching a Frank. Nice one. So we are almost there. Before I finish though, let's restore the enemy movement. In the entity sprite, place the move script back into the when I started clone forever loop before we detect the player collisions. And in the player sprite, we can get rid of that old touching player script. And then, if you want to, we can restore mouse control by finding the define player tick script and simply drop a not block into this if condition. You could of course opt to switch this mode on or off in any way you feel best. Let's give that a quick test. Yeah, there's the mouse. Ouch, something is already attacking me. But tell you what, let's hide those excess variable reporters, player Z and speed Z, and that, my friends, is what you'd call a wrap. And isn't this game looking fantastic? I do hope you've enjoyed re-engaging with this series. If so, then please like the video, and if you haven't already subscribed to my channel, then why not subscribe now? Checking that bell icon to ensure you are the first to know when the next video drops. If you are keen to see more videos in the Raycaster series, then drop me a comment because I still have a number of topics to explore, like projectiles, viewing enemies from different angles, or perhaps even bringing Cloud Multiplayer Engine into the mix. Anyhows, apart from to remind you that I have a glorious selection of the most practical merch available for the keenest of channel supporters, that is it for today. So have a great week ahead, and scratch on, guys.